All right, guys and gals, we are on section 7, similar triangles. So as you recall, similar polygons happen when two polygons are similar if their corresponding side angles are congruent and their corresponding angle lengths are proportional. Okay? When it comes to triangles, there are certain shortcuts that we can use to show similarity. You do not have to know every side length and angle measure. But recall, these shortcuts do not work for other polygons, meaning quadrilaterals. Okay? If you have a quadrilateral, you still have to have all sides and angles, and you have to use the formal definition. Okay? So we're going to go ahead and define these shortcuts for triangles. So we have side, 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 similarity. Okay? Two triangles are automatically similar if all three pairs of corresponding side lengths are proportional. You do not need to know the angle measures. So here's an example of that. So I could say that this side length is A, B, and C. Okay? I could say that this other triangle then is 2 times as big as A, 2 times as big as B, and 2 times as big as C. I might also be able just to give you the direct numbers. So I could say that this side here is 3, 2.5, and 1. If I took those times 2, I could have 2, 6, and 5. Okay, so those sides are not congruent, but those side lengths are a scale factor of times 2 that are proportional. Next example. Next shortcut, I should say, is angle, angle. Remember, we don't have to have all 3 angles. We established because of the third angle theorem, we only have to have 2. So if 2 triangles are automatically similar if 2 pairs of angles are congruent. You do not have to know the last angle measure or any of the side lengths. So again, I might just have symbols. I might say that this angle, that they're congruent here. And that would be enough information to say, hey, these have to be similar. I could physically or actually give you the numbers. I could say that this is 40 and 30 degrees. I could say this is 40 degrees and 30 degrees. Now, I guess if I'm thinking about that this is an acute angle, I might need to say 60 degrees, 50, 60 degrees, and 50. That way that third angle is actually acute. Okay? So now on our last shortcut here, we have side, angle, side. Now this angle has to be between. This angle can't be over by itself because then it's the bad word. So if this is, two angles are automatically similar if two pairs of corresponding side lengths are proportional and the corresponding angle between those sides are congruent. The angle has to be in between. You do not have to know the third side or the other angle measures. Okay? So a couple examples here. I could say that this side length is A. I know this angle. This side length is B. This could be twice as big as A, included angle twice as big as B. Or again, I could give you the actual numbers here. I could say that this side is 6, included angle with 4. And then if this triangle here is rotated a little bit, this side then would be 8, included angle with a side of 12. All right, and number 1 down here, it says, draw an example showing just because two quadrilaterals have proportional sides, it doesn't make them similar. So I'm going to start with a rectangle over here of 3, 5, 5, and 3. Okay, so if I have these sides, I could have a shape that's twice as big. And my sides could be proportional. I could say that this is 6, 10, 10, and 6. Okay? Sides are proportional, but are those angles the same? Definitely not. I have right angles over here, okay, and I don't have them over here. So you do not have to have the angles drawn, okay? But you can have an answer here of NEI. This does not, just because the sides are proportional, does not force angles to be congruent. So shortcut does not work for this quadrilateral. So we have some examples here. I'm going to give you about 2 minutes to try as many of these as you can. I want you to look at the picture and decide, do you have enough information to say that they're similar? You also might see that they are congruent. So we're mixing up on these examples here. We're mixing in similarity and congruence together. Okay? So we're combining similarity and congruence. Take a couple minutes and see what you can determine here, and then we'll go through the answers. If you write similar or congruent, make sure you write the shortcut. You also have an option of neither. If they're not similar or congruent, you could write neither. let's go ahead and see how we're doing on this. So on A, we have sides 6.5 to 13, 2.5 to 5, and 6 to 12. Hopefully you guys would all agree that this would be similar by SSS. Now, you can write on your paper, side, 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 similar. Okay? What about B? Not enough information. Are you sure? AA. Angle, angle, similarity shortcut. On C, we have 10 to 20, 5 to 15. This is neither. There are physical numbers here, guys and gals. This is neither. The sides are not the same or proportional. Okay, those fractions would not equal each other if you line them up. D, 5 to 15, 3 to 9. These sides are proportional, however, there's not enough information. NEI. When you have a quadrilateral, you must have angles. On E, I have tick marks, so I'm looking now for congruence. When you have tick marks, we're looking for congruence. Side angle side, side angle side. So we have side angle side congruence. Now on F, I'm checking here, 7 to 21, 5 to 15. This is side angle side setup again, and similar. These numbers are the same scale factor. So again, on your paper, you can write side angle side congruent, and on F, you could write side angle side similar. So this concludes your notes for section 7.